It's easy to feel small in the face of such enormity. With billions of cells out there, each one potentially hosting planets and even life forms, we can just assume that we're just tiny specks in the grand scheme of things. We send probes to distant planets, launch telescopes into space, and walk to the moon. And yet, we have barely scratched the surface of what's possible. However, imagine if all of us humans developed a thirst for curiosity and continue to explore and push the boundaries of what's possible. The universe is a place of limitless possibilities after all.
Mr. Alasan, are you listening to our discussion?
Yes, sir. Huh? Universe? Science? Life?
I hope you take science more seriously, Mr. Alasan. It is a language to our universe.
Have you ever heard of a positive feedback? No, it's not just a compliment or a pat on the back. Positive feedback is a physiological mechanism that plays a vital role in our bodies. Let's take a closer look. In our bodies, there are feedback mechanisms that help maintain balance and stability, called homeostasis. One type of feedback mechanism is positive feedback, which reinforces a particular action or process, leading to the amplification of the initial stimulus. Think of it as a snowball rolling down the hill, getting bigger and bigger with each rotation. Positive feedback works in a similar way, amplifying a process until a specific goal is achieved. An example of positive feedback in action is shivering. When we cold or our body temperature drops below a set point, our muscle contract involuntarily, producing heat. The heat generated by muscle contraction raises our body temperature, which stops us from shivering. This is a positive feedback loop that helps our body to reach its goal of maintaining stable temperature. Another example of positive feedback is during childbirth. As the baby's head pushes against the cervix, nerve signals are sent to the brain, which releases a hormone called oxytocin. Oxytocin stimulates the uterus to contract, pushing the baby further down the birth canal. This, in turn, causes more pressure to the cervix, which triggers the release of more oxytocin, and so on. This positive feedback loop continues until the baby is born. Positive feedback isn't just limited to physiological processes. It is also a useful tool in achieving our goals. For example, when we exercise, our body releases endorphins, which gives us a feeling of pleasure and euphoria. This feeling can motivate us to continue exercising and reach our fitness goals. So the next time someone tells you that you're doing a great job, remember that positive feedback isn't just good for our ego. It is also a fundamental mechanism that keeps our body functioning properly and helps us achieve our goals.
To begin with, let us first know the concept of Faraday's law of induction. Faraday's law of induction is a fundamental principle of electromagnetism that describes the relationship between a changing magnetic field and an electric current. The law states an electric current is induced in a conductor when there is a change in magnetic field that passes through it. The law has a wide range of applications in modern technology and is used in many devices.
In generators. Generators are machines that convert mechanical energy into electrical energy. They work by rotating a coil of wire inside a magnetic field, which causes an electric current to be induced in the wire. This current can then be used to power devices or stored in batteries for later use. Generators are used in different applications, from large power plants to small portable generators or camping trips. In transformers. Transformers are devices that use induction to transfer electrical energy from one circuit to another. They work by passing an alternating current through a coil of wire, which creates a changing magnetic field. This field then induces a current in a second coil of wire, which can be used to power devices or to transmit electricity over long distances. Transformers are used in different applications, including power distribution systems and electronic devices. Faraday's law of induction is also used in many medical devices, such as magnetic resonance imaging machines, or MRI. MRI machines use strong magnetic fields to create images of the body's internal structures. These machines work by inducing a current in the body's tissues, which creates a magnetic field that can be detected and used to create an image.
In addition to these practical applications, Faraday's law of induction is also used in many scientific experiments in research studies. For example, it is used in studies of Earth's magnetic field as well as in the studies of behavior of atoms and molecules in magnetic fields.
In conclusion, Faraday's law of induction has many real-life applications, from generators and transformers to medical devices and scientific experiments. Its fundamental principles have helped to shape modern technology and to continue to be cornerstone of the understanding of electromagnetism.
In this part, we will be dealing with stoichiometry. We're going to break down the basics so you can understand it easily.
That sounds great. I heard about stoichiometry, but I'm not exactly sure what it is.
Well, in simple terms, stoichiometry is a branch of chemistry that deals with quantitative relationship between reactants and products in chemical reactions.
Okay, I think I get it. So how do we calculate these relationships?
That's a great question. We use stoichiometry equation, which is a balanced chemical equation that shows the mole ratios of the reactants and products.
Got it. Can you show me an example?
Sure, let's say we have the chemical equation of 2H2 plus O2 yields to 2H2O. This equation tells us that 2 moles of hydrogen gas react with 1 mole oxygen gas to produce 2 moles of water.
Okay, I think I'm following, but how do we use this information to actually calculate something?
Well, let's say we have 4 moles of hydrogen gas and 2 moles of oxygen gas. We can use the stoichiometric equation to determine how much water we can produce.
That makes sense. But is there anything else I should know about stoichiometry?
Well, there are a few things to keep in mind. First, it's important to always balance the chemical equation before doing any calculations. Second, be sure to use the correct units when making calculations. And finally, make sure you're using the correct stoichiometric coefficients for the reactants and products in that equation.
Okay, those are some great tips. Thanks for explaining stoichiometry to me.
No problem. I'm glad I could help. And to all our viewers out there, thanks for watching. We hope you learned something new today.
And that's it for our discussion. Remember, we may be small, but we're also capable of great things. Right, Mr. Alasan?
Huh?
For further announcement class, please do open your Moodle and check the quizzes that I have opened yesterday. And check that Moodle. Check this out one.
Stoichiometry.